In this module, we discuss about prompt injection, jailbreaking, and AI system abuse. As large language models become embedded in workflows, products, and decision support systems, a new category of security risk emerges, not from breaking the model, but from talking to it the wrong way. Prompt injection and jailbreaking do not exploit software vulnerabilities in the traditional sense. They exploit how language models interpret instructions, context, and authority. This section explores how AI systems can be manipulated through language itself, why these abuses are structurally difficult to eliminate, and what this means for governance and safe deployment. While language is an attack surface, traditional systems separate code from input. Language models blur that boundary. Instructions, data, and context are all derived through the same channel, text. The model does not inherently know which parts of an input are trusted instructions and which are untrusted data. Everything is language. Everything competes for influence. This makes language itself an attack surface. What prompt injection really is? Prompt injection occurs when an attacker crafts input that causes a model to ignore, override, or reinterpret its original instructions. This can happen when user input is combined with system prompts, external content is passed into the model, and context is dynamically constructed. The model is not being hacked, it is being persuaded. From the model's perspective, it is simply following the most statistically compelling instruction. Direct and indirect prompt injection. Prompt injection comes in two broad forms. Direct injection involves explicitly telling the model to disregard prior instructions. Indirect injection embeds instructions within data the model is asked to process, such as documents, emails, or web content. Because the model cannot distinguish intent, embedded instructions can be executed unintentionally. This makes any untrusted input potentially dangerous. Jailbreaking as instructional subversion. Jailbreaking refers to attempts to bypass safeguards designed to restrict model behavior. These techniques often involve reframing requests, using role play, exploiting ambiguity, and gradually escalating instructions. Jailbreaking is not about technical privilege escalation, it is about narrative manipulation. Attackers test which phrasing convinces the model to comply. Why models are susceptible to jailbreaking. Language models are optimized to be helpful. They are rewarded for following instructions, being cooperative, and providing useful responses. This helpfulness creates tension with safety constraints. When instructions conflict, the model resolves ambiguity probabilistically, not ethically. This makes constraint enforcement inherently fragile. The illusion of lockdown AI systems. It is tempting to believe that models can be fully restricted. In practice, any system that accepts untrusted input, generates natural language, or operates across contexts faces ongoing abuse risk. Prompt injection is not a bug that can be patched away. It is a class of vulnerability tied to how these systems work. Why AI abuse scales easily. Once a successful jailbreak or injection technique is discovered, it can be reused endlessly. There is no need to exploit memory corruption or system specific flaws. Language based exploits are portable. This makes abuse low cost, high impact, and difficult to attribute. AI misuse scales faster than traditional attacks. Abuse without malice. Not all AI system abuse is intentional. Users may provide poorly structured prompts, combine data and instructions carelessly, assume the model understands boundaries, and the result can be unsafe output without malicious intent. From a governance perspective, impact matters more than intent. Prompt injection in integrated systems. Prompt injection becomes especially dangerous when AI systems are connected to databases, APIs, automation tools, or decision workflows. A manipulated model output can trigger downstream actions. This turns linguistic manipulation into operational risk. Why filtering alone is insufficient? One common response to AI abuse is filtering, blocking certain words, phrases, or outputs. Filtering helps, but it is reactive. Attackers adapt language, they rephrase, they evade patterns. Because meaning can be expressed in many ways, filters struggle to keep up. Defense must be layered, separating instructions from data. One mitigation strategy is structural separation. Systems should clearly distinguish system instructions from user data, minimize dynamic prompt construction, treat all external content as untrusted. This reduces but does not eliminate injection risk. The model still processes language holistically. Human oversight as a control. Because models cannot reliably police themselves, human oversight remains essential. Critical outputs should be reviewed, validated, contextualized, and automation without supervision magnifies risk. This is especially true in financial and regulatory contexts. Why AI safety is about system design. Prompt injection reveals a broader lesson. AI safety cannot be achieved by model behavior alone. It depends on how systems are architected, what inputs are allowed, where outputs are used, and who is accountable. Language models are components, not decision makers. Why this matters for governance? Prompt injection and jailbreaking undermine assumptions about control. They show that guardrails are probabilistic, that compliance cannot rely on model intent, and responsibility remains human. Effective governance treats AI as a high risk interface, not a neutral tool. The key takeaways are prompt injection and jailbreaking exploit the fundamental nature of language models. They do not break systems, they persuade them. Because language is the interface, abuse is inevitable. Managing this risk requires structural controls, human oversight, and realistic expectations about what AI systems can and cannot be trusted to do.